will discuss on spherical mirrors. Spherical mirrors are those mirrors whose reflecting surface is part of a sphere. We'll take an example. My dear, suppose this is a sphere. This is the center of a sphere. Center of a sphere is known as center of curvature. And suppose outward surface of this part of the sphere is polished. And my dears, now I will erase this part. Actually, this part of the sphere. And reflecting surface is, my dear, this side. Inward surface is reflecting surface. Outward surface is polished. So, dears, reflection will occur on this surface. This mirror is known as concave mirror. Concave mirror is that mirror whose outward surface is polished and reflection occurs on inward surface. Central point of this reflecting surface is known as pole of the mirror. Straight imaginary line which passes through center of curvature and pole of the mirror is known as principal axis. My dears, if rays of light parallel to the principal axis will fall on the inward surface, reflecting surface of this mirror, so these rays will get a reflect and will meet at a particular point on principal axis. My dear, that point is known as principal focus, denoted by capital F. Distance from principal focus F to P is known as focal length, denoted by small f. My dear, distance from center of curvature to pole of the mirror is known as radius of curvature. And distance from principal focus to pole of the mirror is known as focal length. And this point is known as principal focus. Principal focus is the point why rays of light, my dears, meet on principal axis. My dear, center of curvature, distance from C to P is twice. Then, my dear, focal length. Means the distance from C to P is 10 centimeters. Then distance from F to P, focal length is only 5 centimeters. Second, my dear, mirror is convex mirror. Suppose this is a sphere. This is the center of a sphere. Center of a sphere is known as center of curvature. If convex mirror is, my dear, mirror whose inward surface is polished. And reflection, my dears, occurs on outward surface. I will erase, my dears, this part of sphere. Central point of this reflecting surface is known as pole of the mirror. A straight imaginary line which passes through center of curvature and pole of the mirror is known as principal axis. Principal axis. Reflecting surface of this mirror is outward surface. So, my dear, this one is convex mirror. Convex mirror is mirror whose outward surface is reflecting surface and inward surface is polished surface. So, yes, if rays of light parallel to the principal axis will fall on this mirror, on outward surface of convex mirror. So, my dears, these reflected rays will move away from principal focus. That's why this concave mirror is known as converging mirror. Because it converges rays of light, reflected rays of light at a single point. Whereas, my dears, convex mirror is known as diverging mirror. It diverges reflected rays, not it converges.
It's associated with spherical mirrors. Hello students, have you ever visited a dentist? You may have seen them use a small concave mirror to check your teeth. Can you recall any other place where you may have seen a concave or a convex mirror? You may have also seen concave mirrors being used in the headlights of vehicles and convex mirrors being used as rear view and side view mirrors. Concave and convex mirrors are known as spherical mirrors. Do you know why? They are known as spherical mirrors because they are always a part of a bigger imaginary sphere. A concave mirror has its reflecting surface curved inwards. On the other hand, a convex mirror has its reflecting surface curved outwards. Let us represent the sphere that the mirror is a part of using its cross-section, that is, a circle. The center of the imaginary sphere that the mirror's reflecting surface is a part of is called the center of curvature of the mirror. It is denoted by the capital letter C. Note that the center of curvature of a concave mirror is in front of it, whereas the center of curvature of a convex mirror is behind it. The center of the reflecting surface of the spherical mirror is known as the pole of the mirror. It is denoted by the capital letter P. The distance between the points C and P is the radius of the sphere and is known as the radius of curvature of the mirror. It is denoted by the capital letter R. The line that joins the center of curvature and the pole is known as the principal axis of the mirror. Observe that the outline of the reflecting surface of a spherical mirror is circular. The diameter of this circular outline is known as the aperture of the mirror. When parallel light rays from a distant object strike a concave mirror, they converge to a point on the principal axis after reflection. This point of convergence is known as the principal focus F of the concave mirror. In case of a convex mirror, the light rays from a distant object appear to diverge after reflection. The reflected rays appear to diverge from a point on its principal axis behind the mirror. This point is known as the principal focus of the convex mirror. The distance between the principal focus F of a mirror and its pole P is known as the focal length of the mirror. It is denoted by the small letter f. For spherical mirrors of small apertures, the radius of curvature is twice the focal length of the mirror. This means that R is equal to 2f. So, what does this tell us? This tells us that the principal focus F is exactly at the center of the line segment PC that represents the radius of curvature. Let's summarize. Pole P is the center of